Our last speaker of the afternoon is Dr. Yana Bebieva, and she is from the Geophysical Fluid Dynamics Institute, and she's going to speak to us about wildfires, the Force Awakens. Take it on away.
Thank you. So hi, everyone. My name is Yana Bebieva. I'm from the Geophysical Fluid Dynamics Institute. This work was done together with my advisor, Kevin Spear, and also researchers from the Department of Scientific Computing and the United States Forest Service. Well, these and last weeks saw the worst outbreaks in the month-long burst of wildfires in California, Oregon, and Washington. Burned homes, thick smoke, shattered lives. And these are just a few things on the list of wildfires aftermath. Each fire season in the US has gotten progressively worse. However, it is still not clear how wildfires spread. In our lab, we address this question. Before I dive into the physics of the fire spread, let me talk a little bit about the structure of the lowest part of the atmosphere. We call it the boundary layer. This layer has a few other layers shown schematically here. In our lab, we focus on the processes determining the fire spread in the lowest of all the layers, the fuel layer. This layer consists of leaves, branches, and pine needles. To illustrate how the fuel layer influences the fire spread, let's do a simple experiment. I will come back after this experiment and walk you through it, but now just enjoy. All right. All right. So as the flame burns, it hits the air inside the halo center of the tea bag. As the air gets hotter, the molecules become less dense and move up. This generates a horizontal flow at the bottom of the tea bag. This lifts the bag, and the inflow of oxygen also fuels the fire. Since the tea bag is so light, it rises with the warm air and appears to fly. If there were some obstacles at the bottom, the air would move slower, and the upward movement of the air, and therefore fire, would be much slower as well. In our lab, we characterize horizontal velocity of the air depending on the type of the fuel layer. And can I ask you, do you see my screen? Debbie?
Yes, you're fine.
Good. So a few years ago, a group at GFDI, together with the Tall Timbers Research Station, that is right to the north of Tallahassee, did some experiments with the prescribed fires. We used several instruments to measure the wind speed, an anemometer, that is commonly used weather station instrument. It consists of 4 hemispherical cups mounted on horizontal arms, which are mounted on a vertical shaft. The airflow past the cups in any horizontal direction turns the shaft at a speed roughly proportional to the wind speed. We also use some modern instruments like Zafra LiDAR. It measures velocity from 1 meter above the ground to hundreds of meters. Applying some theory to our observations, we estimated velocity in the fuel layer. Those are first ever produced estimates of the velocity in the fuel layer. So here you see height and U, and we estimated these points. Next, using these estimates and a simplified 1D model, we predicted the spread of surface fires. So the next step is to explore how wind spreads through different types of fuel in a wind tunnel. So here you see a picture of the wind tunnel, and as a fuel, we used pine needles. The impact of this work is pretty straightforward. Understanding the wind flow through the fuel layer will help us understand the spread of wildfires and hopefully save lives, properties, and forests. Thank you.
Great job.